here we are given that there are two P players, P1, P2. Let's denote xi be the ith role of P1 and yi be the ith role of P2. Small xi and capital Xi be the total score of P1, so x1, and x2 be the xi be the total score of P1 after the ith role, and yi be the same for the player P2. So we need probability x2 greater than or equals to y2. So let's break that down into cases. Case 1, x1 greater than y1 and x2 greater than y2. Then we have x1 greater than y1 and x2 equals to y2. We cannot have y1 less than x1 or y2 less than x2. We can, in fact, because we can have x1 less than, or let's take this case, x1 equals to y1 and x2 greater than y2, and we have x1 equals to y1, x2 equals to y2, and then we have so notice in the first four subcases capital X2 would be greater than capital Y2, and in these two cases X2 would be equal to Y2. So by doing this segregation, we will get both the answers for both the first and second parts. So let's quickly calculate probability x1 greater than y1. So we'll have recall when this is our probabilities 1 2 3 4 5 6 1 2 3 4 5 6. Then these are these 6 diagonals. In these 6 cases we have xi equals to yi, and here we have xi less than yi, here we have xi greater than yi. So that becomes 15 by 36. 15 by 36. The probabilities of xi greater than yi is 15 by 36. Probability xi less than yi is 15 by 36. And both being equal is 1 by 6. That is 6 by 36. So this probability becomes 15 by 36 squared, because this is 15 by 36 multiplied by this is also 15 by 36. This is 15 by 36 into 1 by 6. This also is 15 by 36 into 1 by 6. And this is 1 by 6 squared. So adding all these, we get 15 by 36 squared plus 2 into 15 by 36 into 1 by 6 plus 1 by 6 squared, which is 15 by 36 whole square. This turns out to be 15 by 36 is 5 by 12, 7 by 12, which is 49 by 144. So this is probability. Okay. Now for the last two cases, these two will have the same probabilities. These two will have the same probability. Okay, so this will have the probability 15 by 36 squared, and so this also will be 15 by 36 squared, which will be, so the total probability for these two is 2 into 15 by 36 is 5 by 12, which is 25 by 144. Adding these two, we get 99 by 144, which is 11 by 16. So first is map to Q. First answer is Q. For second, we have probability of x2 greater than y2. So that includes this case, this case, this case, not this one, not this one, not this one. So we have these three cases, which means 49 by 144 minus 1 by 36. So it was this minus this, or let's add these anyway. So we'll get by 36, this is 5 by 12 squared is 25 by 144, plus this is 5 by 12 into 1 by 6 is 5 by 72, this also 5 by 72. So this becomes 5 by 36 is 45 by 144, which is 5 by 16. So 2 is mapped to R. Now for third, Px3 equals to y3 is Px2 equals to y2 multiplied by Pxi x3 equals to y3, right? Plus we'll have to make cases again. So for the third, Px3 equals to y3, so that will be the first one wins 1, second one is 1 by 2, and the third is tie, or all the three are tie. Yeah, these are the two cases. Rather, this subcase 1 is all three tosses tied. Subcase this one is one toss or one roll won by one won by P1, one won by P2, and one tie. So probability of all the three ties is 1 by 6 cubed. Probability of this is P1 winning is 5 by 12, P2 winning is 5 by 12, 5 by 12, P2 winning is 5 by 12, and the tie is probably the probability of a tie is 1 by 6 into 3 factorial, because which game is won by who and which game is tied. So there are 3 events and there are 3 places to keep them. So yeah, so this becomes 25 by 144 plus 1 by 216. This is equals to, this is 6 into, this is 36 into 4, this is 36 into 6, so it becomes 75 plus 4 by 75 plus 2 by 36 into 12, which is T. So 3 is mapped to T. So we still don't have our answer. It can be from anyone from A to B. So probability of x3 greater than y3. So x3 will be greater than y3 if all the 3 are won by the player 1, or 2 are won, 1 is tied, or we have 1 I, 2 T's, or we have one player winning 1 role win by player 2, and the third one also 1 by 1. Have 1, 2 and a tie. I think these are the 3 cases. 1 1 1, 1 1 T, 1 T T, yeah. So the probability for this, all the rolls won by player 1 is 5 by 12 cubed. This is 3 into 1 by 6 into 5 by 12 squared. This is 3 into 1 by 6 squared into 5 by 12. This is 3 into 5 by 12 cubed. This is 6 into 5 by 12 squared. 6. Now this case won't be counted because in this P3 would be equal to x3 would be equal to y3. We don't need that. We need them to be equal. We need them to be strictly x3 is strictly greater than y3. So this becomes 5 cubed into 4 plus 5, 25 by 288. This becomes 25 by 288 plus this is 5 by 144. This is 35 by 288 plus 125 by 144 into 3. This is 144 into 2. The 4 into 6, 50 plus 1 5. This is 355 by 864. So yes. So the answer is option A. So this was a long question, but fairly straightforward, simple P and C and probability.